Okay guys, welcome back. We're looking at chapter 23B still, and now we're doing example 4 on page 613. So we've got a bag of marbles. There's 4 red and 2 blue marbles in the bag. So 4 red, 2 blue marbles in the bag. 2 marbles are going to be randomly selected without replacement. So that might happen simultaneously or it might happen one at a time, regardless, because without replacement, the same situation occurs. X denotes the number of reds selected. Okay, so let's underline that in red. X is representing the number of reds selected. Okay, so find the probability distribution of X. Okay, to do that, easiest thing for us to do will be, gosh, can I get the top of that marker? Let's see. The easiest thing will be a tree diagram. Let's draw a tree diagram to represent this situation. Okay, so we've got our first marble being selected. It could result in a red or a blue. And then the second marble being selected, represented by our second set of branches. Second marble. And the second marble could also be red or blue. Red or blue in this situation, red or blue in this situation. And I'll add the blues in. Okay, so what are the probabilities of each of these things happening? Well, when the first marble comes out, because there's 6 marbles in the bag, these probabilities will be out of 6. Okay, so there's 4 out of 6 chance of getting a red, 2 out of 6 chance of getting a blue. And you could reduce that fraction if you want as well. Okay, then after that one is taken without replacement, there are now 5 marbles left. I'll have to get rid of that so I have space to say out of 5 for all of these probabilities. And remember, without replacement means if I already have a red, then that means there's now only 3 red in the bag. Okay, so probability of getting a red is 3 out of 5. Both of the blues are still there, so 2 out of 5. If I had already selected a blue, there's still 4 reds in the bag, so that's 4 out of 5. But 1 blue is already taken out, so now there's only 1 blue left. Okay, so what are the probabilities of each of these things happening? And what are the results of what is happening? Okay, so let's take a look at that. The results of this pathway, red, red, means we have 2 reds. The results of this pathway, red, blue, so we have a red and a blue. The result of this pathway, we have a blue and a red. And the result of the last pathway is we have a blue and a blue. Okay, and the probabilities of each of those things. Here we have 4 out of 6 multiplied by 3 out of 5. Okay, I am going to reduce this fraction to make it a little easier. That's the same as 2 out of 3. This is the same as 1 out of 3. Okay, so this is 2 out of 3 multiplied by 3 out of 5. So remembering how to do all of this. 6 out of 15. I'll leave it like that for now so we can compare them. This pathway, 2 out of 3 multiplied by 2 out of 5. So that's 4 out of 15. This pathway, 1 out of 3 multiplied by 4 out of 5. So 4 out of 15. Okay, makes sense because we ended up with the same thing here, same probability. Okay. And the last pathway, 1 out of 3 multiplied by 1 out of 5 is 1 out of 15. Now remember, each of these probabilities must be between 0 and 1, and they all must add up to 1. So if we add them all up, 10 out of 15, 14, 15 out of 15, that equals 1. So this is a good probability distribution. Find the probability distribution of X. Okay, we're not finished yet. Now we need to say, and I'll continue down here. Now we need to say the probability that X is equal to 2, because remember, X represented the number of reds selected. So the probability that X is equal to 2, that means 2 reds, is 6 out of 15. And we can reduce that now. 3 goes into both, so 2 out of 5. The probability that X is equal to 1, so this case and this case, okay? One red in both of those situations because X is represented by the number of reds. So add those two together. So that's 8 out of 15. And the probability that x equals 0 means that, oh, we ended up with 2 blues, 0 reds. So the probability x is equal to 0 is 1 out of 15 in this case. So that is the probability distribution. Okay, this is the final answer. The tree diagram was how we got there. All right, now illustrate with a spike graph. Okay, so spike graph, remember, is, and just so you know, I've never seen an IB question that is asked to draw a spike graph. Not saying that it couldn't happen, but I've never seen one. So we draw a graph here. The x-axis is what x is equal to, 0, 1, or 2. So I'll put 0 here, 1, 2, because it's a spike graph. And up here is our probability that x is equal to that x value. Okay, so we have 6 out of 15, 8 out of 15, 1 out of 15. So let's make this, here's 1 up here, okay, and I have 15 little grid spots, which comes out very nicely. So the first one with 2 is 6 out of 15, so that means here. My spike graph comes up to there. Second, x is equal to 1 is 8. 5, 6, 7, 8 comes up as far as here. And 0 is 1, only 1. Okay, so there's the spike graph. And there we have it. Example 4 done.